Okay, so in this section, we are going to be finally proving congruence of two different triangles. What it means to be congruent is that all sides and all angles are going to be congruent. So, for example, if I look at this picture, if triangle ABC is congruent to triangle DEF, that means that triangle E is congruent to triangle B. And also side AC is congruent to side DF. Now, if you remember in a previous section, we looked at corresponding parts of congruent triangles are congruent. That means that the same positional angle or same positional side is going to be congruent to a different triangle. Now, there are four main ways to prove them. Actually, there's a fifth way, but not as important. But the four main ways we're going to break down to 2 and 2. So this lesson looks at side, 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 or SSS, and side, angle, side, SAS. Well, side, side, side is really straightforward. If we can prove that three sides are congruent, so here AB is congruent to DE, and BC is congruent to EF, and AC is congruent to DF, then that means that these two triangles are congruent. So the theorem states if three corresponding sides are congruent, then the triangles are congruent. Specifically, triangle ABC is congruent to triangle DEF. And don't forget, when we look at this in order. So AB is congruent to DE. So AB and DE. If I look at angle C, that's going to be the same as angle F. So C and F, those are congruent. So looking at those parts. Now for side, angle, side, this is going to be if two corresponding sides and an angle between them is congruent, or I guess are congruent. All three of them are congruent. Oops. Then the triangles are congruent. So for example, let's say I have angle B is congruent to angle E, side DE is congruent to side AB, and side BC is congruent to side EF. Notice I have side is congruent, angle is congruent, side congruent. It has to be in that order. So if I say AC is congruent to DF and AB is congruent to DE, and I have angle B is congruent to angle E, notice this is side-side angle. That's not what this is saying. It has to be in this same order. It must, whoops, sorry about that. It must be in the same order. It must go side, angle, side. And again, we get the same conclusion that triangle ABC is congruent to triangle DEF. So using these two theorems in addition to everything else we've looked at, we're going to be proving congruent triangles. And so let's actually do that. So this is a proof for side, side, side. Now, please note that when I do this on a test or the midterm or anything in the future, I'm not going to tell you this is a side, side, side proof. All right, so AB is congruent to BC, and BD is the median of side AC. So this just means the median that this is it's going to bisect AC. We actually will look at what the median is more in depth later on. But yeah, that's all it means here. All right, so we're going to look at statements and reasons. All right, first statement is, of course, going to be our given. So AB is congruent to BC, and BD is median of AC. So I can actually mark my picture up. So I'm going to say AB is congruent to BC. Well, I just explained that BD is the median of side AC, so that means that AD is congruent to DC, and that's just the definition of a median. For 3, so AD is DC. For 3, BD is congruent to BD. Why? Well, the side equals itself. That's called the reflexive property. Very important. It seems silly before, but it's actually very necessary now. And it seems pointless to say, but actually I need to show that all three sides are congruent. And by saying that BD is congruent to BD, then I have it on the books that it's congruent, that this third side is congruent. So showing that all three sides are congruent, I'm going to say that triangle ABD is congruent to triangle CBD. And that's because of side, 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 steps 1, 2, and 3. This shows me I got the first side in step 1, it's given, the second side in step 2, and then the third side in step 3, right there. So that's how we show congruent triangles based off of side, side, side. Let's look at another example here, this one using side, angle, side. So again, I'm going to do my statements. My reasons. All right. So first step is going to be the given, and that's BC is congruent to DA, and BC is parallel to AD. Great. So BC is congruent to AD. I got that already. BC is parallel to AD, parallel lines. That should set off alarms. We're going to be looking at all sorts of those angles we looked at first. So I have these sides are congruent, but look at this right in the middle, AC. I can use that reflexive property again, and I can say that AC is congruent to AC, yet again because of the reflexive property. Now, if I look at this triangle ACD, I can see that I have side, side. So all I need to do is to prove that these two angles equal each other, because then I would have side, angle, side, side, angle, side. And actually, if you look, I can prove that they are congruent, because angle BCA is congruent to angle DAC, and that's because when lines are parallel, alternate interior angles are congruent. Right? These are alternate interior angles. These lines are parallel, so that's the alternate interior angle theorem, or writing it out like this. So now I have side, angle, side, so I can actually say triangle ABC is congruent to triangle CDA, and that's from side, angle, side. Going back to step 1, 3, and 2, showing I got that first side in step 1, the angle in step 3, and the second side in step 2. Just a little index for referencing my proofs. All right, we're going to look at these two proofs now, and then another one. Whoops. And that'll be it. So let's look at these two. So I have these two triangles, and this one's pretty straightforward because everything's already given to me. If I look at this picture, I know that AB is congruent to XY. I know, if I do a second step here, I know that AC is congruent to XZ, again, given. And the third step, which is also given, is that BC is congruent to YZ. So I can just right here say triangle ABC is congruent to triangle XYZ, and that's because of side, side, side. I'm done. Now the next one here, I know that RS is congruent to UT because that's given. Number 2 is that RT is congruent to US, which is also given. But I also know that TS is going to be congruent to TS. Why? That's a reflexive property. It's the same line. So if I look at step 4 here, step 4 is just going to be that triangle RTS, or sorry, RST is the way they want to say it, RST, is congruent to triangle UTS, and that's because of side, side, side. And I can actually say steps 1, 2, and 3, and I should say that for the other one here. So steps 1, 2, and 3. Simple enough. So that's just side, side, side. And then here's another example that we can look at. Again, it looks like another side, side, side example. So if we look at these statements and these reasons, so the statement here is that BA is congruent to AD. And I can also say in the same step, why not? BC is congruent to CD. This is all given. So BA is congruent to AD, and BC is congruent to CD. I have that common side that they both share. Whenever that happens, chances are I'm going to have a reflexive property. So that means that AC is congruent to AC. And if I look at my picture now, I have 3 sides. So I have enough to say that ABC is congruent to ADC, and that's because of side, side, side. So those are 3 examples of side, side, side. Chances are, whenever you have parallel lines, you're going to be looking at some sort of angles you need to prove. Luckily, we did a whole section or whole unit on proving that, so hopefully that'll come back quickly. But these 2 main theorems here, side, 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 angle, side, are crucial in proving triangles. So we're actually going to get a few days practice of this in class, and I recommend you do the same. And then we are going to be moving on to some more theorems to help prove congruent triangles.